Hello everyone. Today we are gonna talk about clustering. Most likely we are not gonna use Weka software. Weka is very popular with many different techniques in clustering. You have the manual. You can use it to look around how you can do the clustering algorithm. However, I would like you to work more on very popular clustering software. It's named gCluto. It has many different interfaces, but the one that the most popular and easier to use is the graphical gCluto. First of all, just to give you some hints about what is clustering all about. Let's say that I went to Google and I wrote about news summary. And as you can see, you got a lot of results, some from NPR, some from CNN, some from the Dayton Daily News, and a lot more headlines. If you click on any one of those, let's say the NPR, you can see that the news are related to many different topics. Also, if you wanna, here for example, to give you option to have it as MP3 or RSS feed or as from iTunes. So this is like more podcast. Let's go to the CNN. Okay, also the CNN give you some news. The headlines is here, the latest in news. Don't think about the website as used to be in the past, that webmasters will sit and will design and write each column. That's not true anymore. Those are automatic feedback that the website generate this feedback and put it inside the website. The most famous one is the news that comes from Google. So for example, if you just click on the news, updated news from Google, you can see from here on the left side, past hour, past 24 hours, let's say past hour. So as you can see, you have all the topics. Those topics, all of them are not generated by a human anymore. Machine learning algorithm, most likely clustering algorithm, generate those type of news. Also, I would like you to see the one which is a little bit more like condensed. Yahoo. Yahoo News is very popular because, as you can see, it gives you the timestamp even about all those results. All those are not a webmaster based results. Those are automatically built in, clustered by algorithms and submitted to the website. So the life is not as used to be before, and as you can see, they are based on topic. So it's not human being generating those topics. At the beginning, you have, of course, you put the main topic that you would like your website to be focusing on, but all the information fed inside the website is based on technique that clustering algorithm provide you with. So now you have a little bit idea of what is clustering, but you really don't know what and how you can really manage clustering algorithms. So let's go back to the manual that gCluto comes with, and as you can see that I decided to have this picture from the manual that I added to your unit number 10 as an example for clustering. So for example here it's very difficult. Of course the color can help you to know which cluster to separate them from each other. The blue is separated from the yellow, the blue, but it's really difficult for you to have this adjustment and to be able to have those clusters by themselves. It's very popular concept in the biology in the past, the idea of clustering. Usually you cluster animals, you cluster insects, so the similarity between the same animals, hierarchy. If you want to build a hierarchy tree of all the animals in the world, you start to categorize them, and you start to add the similar animals to the same category. So this is somehow a little bit just to give you more idea of what clustering is all about. Now, of course, to be able to generate the clustering is not an easy concept. A lot of algorithm, a lot of elements need to be considered to be able to understand the clustering algorithm. A lot of criteria and equations need to be considered. However, I'm going to try my best to show you the concept and use the application. In this way you will understand how you can do clustering without going in details into the equations, but somehow if you heard some terminology like entropy or like purity, you will in future you will understand how to measure how good your clusters are and how bad they are. So until now, I guess most of you are not yet understanding maybe the whole concept of clusters. With time we're gonna understand it. First of all, why I applied on text mining, because I feel this is the most closer to your area, which is a computer information system, to understand the text clustering than biological clustering examples or any other area of clusters. Now let us go to the website of gCluto. If you just Google gCluto, George Cripsey is the one who invented this software, and he's very popular. He has a lot of other softwares, and his lab is one of the most famous labs in the world in clustering algorithms. As I said, we have different types. For example, the gCluto is for the informatics, for the genetic algorithm. The one we use is the gCluto. If you look at the gCluto interface, will be as the following, divided into a couple of units. On the left side is how the hierarchy of your data, how it will look. The middle is the solution that you're going to generate. Of course, separately you can visualize your result and see how your results are. And also you can see it in hierarchy level. We may skip this one because a little bit is complicated, but most likely I would like you to understand how you can look at the data graphically and really understand how clusters are separated from each other. Okay, so I think in the time being we can run gCluto. After you download your gCluto algorithm or software, you will be able to see it in this way, and under the folder Windows you will be able to see the gCluto executed file. What I did actually, I just drag it and put it on my taskbar so I can always run it from here instead of going to the folder and remembering from where to run gCluto. So let us open gCluto. I provided you with a data set, sports, which is news about the sports, and I would like you to experiment with this data set. So this is what I am going to do. So I will say new project, this project I will name it sports. Okay, and now I will need to import the data. Let's see what kind of data that you are provided with. So the sports I want you to take under consideration, and we'll talk in details how those data are divided, what the differences between each one of them. But in the time being, just I would like you to run the experiment as an application before even going in more detail. So I picked the matrix that it has the information about the news talking about sports. I don't have a raw file, but I have a column file which is in the same area you will find it in your folder. And I have the raw class actually, and in this case this is the raw class. So you'll find the 3 data available for you in your folder. One of them is the matrix, the second one is the C-label, and the last one is the raw class. And as I said, leave the explanation further, and we'll focus now how you can run the application so you can understand what I'm talking about. So as you can see now, what happened is we saw on the web that if we have a news and this is news related to sports, maybe if I go to the news from here and last hour, or maybe the top stories, or maybe related to sports, so top stories. And now if I am looking at something related to sports, let's just write sports. So this is all the news about the sport. So technically what's happening is each one of those articles has been saved as a Word document. Then after being saved, converted into a matrix, so the gCluto is able to run it. So as you can see, the features here that being extracted from those documents has been listed for you, and next to each one of them it says the value of this feature, how much important this value. Now this, until now, it doesn't give me more information. It's only bunch of words, and I don't see any meaning related to this word. What you can do with your data, you can cluster. So you right click on this data and ask the application to run clustering algorithm for you. As you can see, gCluto comes with 4 types of clusterings, and we're going to go into the theory about those. So I'm doing the opposite way now, just showing you the application first. Then if you want to go and understand the concept behind each one of them, we're going to talk about the theory and the pedagogy behind the running of each of those techniques or algorithms and the equation behind them. So let's say that I would like to have 10 clusters. This is a problem of clustering that is different than classifications. When you classify, remember the simplest data set, which is the weather, to play tennis. Either you play or you don't play. So you have 2 classes. You know from the beginning how many classes you really need. Whereas in clustering, and this is a sport news, I really don't know, based on this old document that I have, how many clusters I will need. So typically what will happen, that you are the one decide how many clusters, and you keep training your data until you find the best clusters that split your data into topics that are different than each other, and inside each cluster they are so similar to each other. So maybe let's say that I have documents related to the mondial sports. So maybe after running the clusters, I was able to have one cluster talking about the football, one cluster talk about the basketball, one cluster to talk about the swimming, etc. So that's really a good clustering if I was able to split those articles and put each information in different. And it's not me manually, the machine learning, the gCluto is going to do this for me. And based on the experiment that I am going to run and repeating those experiments, the results will get better. And I have to tell you, whenever you run the same algorithm, here the method repeated by section and the number of cluster 10, if I keep this configuration and I run it one time again, you will get different results, because the clusters is based on a random pick of clusters as a starting point, as a seed. So every time you run a result and you find the results are good, save those results for a future until you get another result that maybe are better, and then save the better one and proceed. So now let us try keep the way it is, and we are using the similarity functions, the cosine similarity, and we're going to explain this one. And let us run this cluster and see what will happen. So what we are doing here, again, we have documents and we want to cluster those documents in a way that the similar documents will be together and the unsimilar document will be far from the others. This is the results. So what we can see here as a baseball, we have the data set is split in this way. We have many different results as a column: basketball, football, hockey, boxing, bicycle, and golf. So let's see how good our results are here. Two main features I would like you to keep in mind is entropy and purity, and they are opposite each other. And if you sum them up, it equals 1. So here it says the purity of this clustering that I run is about 80%. So technically it's good, but it's not good enough. If I was able to have 100% purity, that's the perfect solution. And then you go and look at your cluster. So you have 10 clusters from 0 to 9. The best solution always will be if you are able in each cluster to have one topic. Like here I can say, okay, the cluster 0, the majority of the articles are related to basketball. So I will say, okay, this cluster is talking about basketball, and I am gonna disregard those 3 articles and the 1 article here. I will say this cluster is related to basketball. The second one, it says I can see that the football is the most one related. Here, for example, number 6, it has a big amount of articles. It has about 1,608 articles, all of them talking about baseball. So as you can see here, you may have more than one cluster related to one topic. Okay, and that's not wrong. As long as you have a cluster that the majority of it or all of it talking about one topic, that's perfect. Okay. Where we have a problem, you can see always the last class, it dumps all the bad results in it. So here I cannot tell which topic this cluster will contain. So all the mistakes that this algorithm I run puts in cluster 9, it says I have 200 articles almost in baseball, 43 in basketball, 111 in football. This is small, so I will not count it. 120, 145, 300 something golf. So really, I cannot decide. That means what I run as an algorithm, it wasn't a good algorithm. So let's try again. Right-click on solution, and I will say recluster. So I'm trying to recluster again, and now maybe I will try some different algorithm. Let's say the graph. Okay, and I will keep this 10. Sometimes you may have to go higher in number of clusters to get a better result. So the application is redoing the clustering, is trying to find a better solution for me, and we'll see if the second method is better than the previous one. As you can see here, I was able to reach lower purity actually, and no, the graph, it didn't work well on this data. If you try to search for the problem where it is, looks to me here I am having a problem. Here also I am having a problem. I cannot guess this cluster is related to which one. So again, I am trying to cluster again, and let's say maybe the direct graph will help me. So I will keep 10 until I give up and find another solution. Okay, let us see if the direct method will give me a better clustering solution for my data. Okay, this is the solution number 3, and this is what I have. So if you remember our solutions, this is one of them, and this is the second one, and that was the third one. So this was the first solution I got about, remember one of the numbers is enough, it's about 0.177. The last one, it was exactly the same, but maybe different result. So it doesn't have to. Also, as you can see, it dumped the result bad at the end. So still, I am not getting good results. So let's try the agglomerative, and in theory, in another video, I'm going to talk about all those methods. I'm just trying to show you how you can use this software. It's more than showing you what the clustering is all about and how the algorithm works. So I have to wait until the clustering getting me a better result, hopefully better than purity, higher than 87%. So that's why for test number 3, try to start from the beginning, because you will have to spend time until you find the best clustering. If I give you a data set to work on, so don't postpone until the last minute. However, you might find the solution from the first day if you are lucky enough to guess a good combination that works well with your data. Okay, bad solution. So the last one is what we're gonna do. I will keep the agglomerative because I know somehow agglomerative works well, and what I'm gonna do now, I'm gonna change the criteria of the function, the way that the criteria of choosing the cluster is working. It's not the method, it's the criteria. So remember to part of the, and I will try to use maybe instead of the default method, I will try to use a single link. We're gonna talk about those and we'll see if I'm gonna get a better result. If not, we're gonna stop with this video here. I don't want it to make it longer, and I will show you how the graphical solution will look. Still, it's not bad solution we are having here. However, we will have to disregard the last cluster if we pick to use one of those clusters. Okay, so let's have this one, the last one, and wish to have a good results. And try to close all the other applications when you are running gCluto. Here we are, solution 5. Okay, very bad, very bad. Okay, so as you can see, it put all the result in the last cluster. So please, when I'm asking you to send me your test, don't send me a data set like this one. Okay, so let us go to the first one and reopen it again, and this is, we got a very reasonable results, not so good. If you increase the cluster, you get better results. So maybe I will just try the last try. I want 30 clusters and see if this will help me a little bit. Sometimes even if you ask for higher clusters, it stops at the cluster. So here we are, we got 90% and it is a whole 30 clusters. So we really got a better, much better result. Let's see our data set. I can assume that this data set is the one that fit. Here we are having problems, so that's why you can see a little bit the data set here is unbalanced, so I cannot guess which one is the best result. Now let us see the results at the visual interface. So if you right click on your solution, you can look at something named create mountain visualization. So it's gonna show you your results as a mountain, and I'll tell you what that means. You can rotate that mountain the way you want it, and not only that, if you see those labels, since we picked 30 clusters, so we have 30 peaks, and if you go to the mountain and ask for the features, what it does actually, it shows you the most important word being used inside those topics that clustered under. For example, let's say cluster 18, Brave, Tiwin, and Atlanta, and 9, the Giant, Jose, and so as you can see, you are more familiar than me than in sports, so you will know that if it's really this algorithm did the job very well by filtering those. For example, here the cluster number 7, and you have to rotate to be able to bring the most important word described in each cluster. Here number 7, the box, playoff, and super. So as you can see, each peak of those, it say that this is a separate cluster. So as you can see, this is a very pure cluster alone. This is a pure cluster. That's why we were able to get good result. However, in some areas, even you can flip it from down and you see how it looks. And in some areas, we were having some mix, and they were really not, there is no hip. Like for example here, I have like a mixed result. That's why we got some articles in the same cluster, very related to each other. Where for example, this one is a pure cluster, this one is a pure, whereas this one we have two clusters sharing this one, and I cannot tell which one is the most important one. This one, it looks like it's very pure, it has high peaks. This one is really pure, as you can see, and you can tell me this is the first one, 0. It was really good. So if you go back to your solution and just look at 0, you can see the purity of 0 is high, about 97, about 98 actually % purity. That's why that peak was so high and so pure. Also the peak number 3, the cluster number 3 is very high purity. I'm gonna stop here. I would like you to play with the data set and to try to use the clustering. I hope a little bit you're getting familiar with the idea of clustering. Let me know if you have any questions. Email me right away, and I'm still waiting for some of your results for test number 2, and hopefully if you have any question, also email me right away. We don't have a lot of time left, 2 days for the submission date, and I would like you to start experimenting with clustering because it's really important topics, very hot topics. Thank you.